There's okay, so what is 5G? How does it work? Why is it different? How do I use it? And then the second part of that, which is the more important part for me, is the final integration now, bringing what was the terrestrial networks together with the satellite networks as well.
Welcome to the Space Angels Podcast, Episode 16, The Promise of 5G. I'm your host, Chad Anderson, CEO of Space Angels, the world's leading source of capital for early-stage space companies. You can find us on social media at Space Angels. In this podcast, we explore what's happening at the cutting edge of this new entrepreneurial space age and speak to the founders and thought leaders at the forefront. Today, we're going to be talking about 5G, which, after years of hype, is finally expected to come online this year. When the number in the corner of our smartphone screens changed from 3G to 4G, few of us even noticed. The same when LTE, another step in the evolution of cellular networks, appeared as an alternative to 4G. However, tech futurists say that fifth-generation networks will support a plethora of internet-connected sensors, vehicles, appliances, and other devices that will perform functions not yet imagined. As our listeners are well aware, space-based technologies are the building blocks of innovation. They're what enable the global economy, and I'm excited to find out what role they'll play in these next-generation networks. That's why I'm so excited about today's guest, Kieran Arnold, Director of Ubiquitous Connectivity at the Satellite Applications Catapult in the UK, and also General Manager at the Westcott 5G Step-Out Center. He's a guy who knows what he's talking about. He was previously head of telecoms at Airbus and CTO of R&D at UK mobile network operator Orange. He now leads the 5G test bed at Westcott, just outside Oxford in the UK. Kieran, great to have you on the show. Thanks for joining us.
Thank you very much.
Okay, so we have a lot to cover today, and I can't wait to dive in. So to start us off, can you tell us a little bit about your background and how you find yourself at the forefront of what's happening in 5G today?
I can. So I spent roughly from graduation in my mid-20s all the way up to my current age now, so just over 30 years in telecommunications. I would say at least 80% of that time I've spent in the cellular world. So I started in 1G. Back in the sort of mid-90s, and I would say actually I've been actively involved in 5G for just over 6 years, and surprisingly I'm starting in 6G very soon. So my background has always been in cellular. I was Chief Technical Officer for Innovation in a well-known cellular operator called Orange, of which most of my time was spent doing research in multimedia communications, basically from 2G to 4G.
Interesting. So we're going to definitely have to touch on that later. I took a tour of the center a couple months ago, and you're doing some pretty impressive stuff there. And there's a lot of international interest in what's going on. So can you tell us what is the 5G test bed in Westcott, and what is it that you're doing there?
Absolutely. So we made a strategic decision just over 5 years ago that while 5G was in its early infancies of being talked about, so, we didn't hear much about it that time ago, that it was going to be a bit of a game changer, and it is different than what we've seen in the previous versions of that. And actually the important thing, the lessons that we learned from the previous generations was actually the important bit is to get people au fait with that technology, find out the gaps in it, and also get people understanding how that will change their business or could be a real game changer and drive profitability, drive reach and things like that. So that's really the essence of what we've been doing around in Westcott. And there are two primary parts of that. There's okay, so what is 5G? How does it work? Why is it different? How do I use it? And then the second part of that, which is the more important part for me, is the final integration now, bringing what was the terrestrial networks together with the satellite networks as well. So we do two important roles. One, which is very much the evangelizing 5G, telling people, I always say that, warts and all, the good, the bad, the ugly of 5G. And then finally trying to work with the standardization bodies and industry partners, SMEs, startups, to try and look at how do we get the satellite to separate networks now integrated into what is we'll call it ubiquitous connectivity, this one network serving all requirements and connecting everybody all of the time. That's really what the essence of what we're doing in Westcott.
Amazing lead in, because I definitely want to touch on those points as well. So everyone, I think, is probably familiar with 4G, the mobile network used around the world to make calls, send messages, surf the web. Now there are plans to replace that with 5G. It's supposed to be a faster network that has the potential to transform the internet. So I'm sure everyone's heard of 5G, but I imagine people don't know much more than that. So what is it actually?
So 5G, the envisioned view of what 5G was doing, we changed from, so 1G to 4G has really been about connecting people. How do I give you a faster connection? How do I get content to you and things like that? Well, 5G really was designed for things. It's not just about us and the internet. It's about devices, it's about sensors, it's about smart watches, it's about vehicles and things like that. So the complexity of that and why 5G is different is because we're not just interfacing to a human who wants to surf the internet. We're talking to a complex sensor in a field that needs to send critical information to a server to make a decision. So the network in itself had to service a lot of things and understand the priority in that data from a device or from a human. How would I give a better service to this device from another device, etc. So there's some great terms coming out of 5G like network slicing and prioritization and preemption and things like that. All of those features and functions help us make the network perform better for individual devices or individual applications. Whereas today in 4G, I'm sorry, it's like going to the swimming pool when there are no lanes and everybody can do their own thing. And you're going to not have such a great experience if you want to train for that Olympic swim. Whereas in 5G, I can dedicate an area of the swimming pool for you now and you can train while the rest of the people are doing their own thing. So that's what 5G is delivering.
Cool. So a lot to unpack there. It's first really the connective tissue for the Internet of Things. That's what you touched on first. And that, of course, is an industry that's set to grow threefold over the next 5 years. It's meant to control robots, autonomous vehicles, medical devices, industrial equipment, agricultural machinery is a big market for this. So would you say that that's true, that first and foremost, it's really about connecting the tissue for the Internet of Things?
Absolutely. The one thing that 5G was designed from the onset is to be able to service many things in a multitude of different ways. So, if latency is important to you, then the network is designed to be ultra low latent. If it's billions of devices I want to get on the network, then I can service a billion of network. And if it's just high speed broadband I want, then I can deliver that service as well. That was engineered into the network, whereas what we found out in the move, especially in 4G, is we have to re-engineer the network to do that. And not all of those things we can service at the same time, whereas we can with 5G.
Okay, and you also mentioned network slicing, which I want to unpack a little bit. So this is a much more personalized web experience, right? It enables separate wireless networks on the cloud, allowing users to create their own bespoke network. The example that I've heard is, let's say, CES, the Consumer Electronics Show, happened earlier this month. There's a whole bunch of people there, a lot of techie people with devices eating up a lot of bandwidth. You need a lot of bandwidth to service that conference, but you might not need so much down the road. Is that aligned with the Olympic swimming pool analogy that you mentioned?
It sort of does. So imagine everyone that says that just wants to get onto, your Facebook, your media streams and that. So what we'll tend to do there is create almost an evolved mobile broadband slice. So really that's just designed to give you as faster connection and as much throughput as I can give you. Now, in that room, there's someone going to be demonstrating robotics, I'm sure of it. And they need an ultra low latency, critically reliable connection to control that robot. So what I do in my network then is I create almost invisibly a part of my network that provides that quality of service metric that does that. And those give priority to certain things. So I'm allowed to slow down the broadband reaction times a little bit because that's not critical to you, but it is critical to my robot that I'm controlling. So the network will give priority to that. And they keep them isolated in a virtual way, not in a physical way. So we're able to maximize the most out of our network as we can without dedicating things. So in other words, there's a good and a bad of the swim lane. If you're not in the swim lane and you're not using it, it's wasted. Where in 5G, I can collapse that capability and offer it to someone else, or I can expand that capability when the need arises as well. So network slicing is really important from a commercial perspective as an operator, because I can service many quality of service metrics across a broad spectrum of users.
How interesting. So from the average person's point of view, the network is going to be much faster. But then there's even this enhanced capability that you can slice off for specific applications.
Absolutely. I mean, the move from, in my days of 1G to now to 5G, and when we move forward beyond 5G, has always been about throughput and efficiency. So what we call spectral efficiency. How do I get more speed out of my network without taking up too much resource? And I think that will carry on in the future across, many iterations of what we'll see in the next sort of decade.
Okay. I've also heard this 5G defined as a software-defined network, so really largely operating on the cloud. And is it going to be able to replace wires? Are we going, is this allowing us to move from a cabled, wired world to completely wireless?
I think it is a first step. I think today that, there are some advantages of being completely mobile. If you're on a cable connection or if you're on a DSL connection at home, when you're away at work, you're not really using that facility. So it's an investment you've made, but you tend to use it only like 50% of the day. Whereas we start looking at a wireless broadband service like 5G, then you can make use of that service anywhere, anytime. It's ubiquitous in its very nature. So, maybe state this now, that the future probably is going to be some form of wireless connection driving that, or at least catching up with fixed line connection. And some people may choose that that's the best way that meets their needs, as opposed to, a fiber optic connection or a wired connection in the future. So I think there's still certainly requirements for a fixed line connection. But equally, I think what you see from consumers and businesses, that wireless is sort of the near enough de facto connection, and it meets their needs today. So I think 5G plays a really important part in keeping up with the speed requirements, the throughput requirements, and being purely wireless as well.
How interesting. So, okay, 5G was created years ago, around 2015, and has been talked up ever since. But 2020 is supposed to be the year that it comes online. And in fact, the drum roll got louder and louder at CES, the big consumer electronics show in Las Vegas, where companies were promising everything from augmented reality glasses to autonomous vehicles, mobile streaming services, all of which are going to get a boost from this new technology. So curious, what applications do you see for this? Is it the ones that I mentioned, or are you seeing some other things?
I think predominantly, it still very much is about enhanced mobile broadband. So things like augmented reality, virtual reality. I think the technology curve where we are in that sphere of work is very advanced. Neural network processing and things like that, where we're starting to see advance. We're now seeing a network connection that provides a hugely faster connection than previous ones. So I think you will start to see more of the augmented reality being used more. So, providing additional information to users or businesses as that, you can see that coming online. Certainly, I see that a lot in driver information systems, people walking and trying to get information on the move, etc. So augmented reality as a real pro point. You're starting to see that now in some of the, sports apps that we see, where they're mixing real video with augmented reality, and that we're able to do that in real time as well. I think further down the line, you'll start to see the more connected things, so harvesting information for health, harvesting information for the agri-tech business as well, rather than doing what we do traditionally, which is go out in a field and measure something. I think that will be censored in the future, and we'll start to see people acquiring data and analyzing data near enough in real time and making decisions on that as well.
Fascinating. So I want to touch a bit on the challenges. In the US, network providers are already starting to roll out what they're calling 5GE networks, so pre-5G deployments. And they've made a lot of promises. And at the same time, we're starting to see some articles in the news and things about how the 5G rollout's going to fall short of expectations. And I think if you read some of what's out there, a lot of it seems to do with the workforces that are available, trained and the infrastructure that needs to be built from smarter cell towers and the like. And so, how true are those concerns, and what are the challenges that you see in terms of rolling this out?
So definitely there are some challenges in this. So maybe, because 5G gets delivered in two flavors, what we call non-standalone mode and then standalone mode. So we're in the first phase of 5G, which is non-standalone. So I'll explain that to you. So that is only, let's say, half a network. It's only the radio network of 5G. We don't do anything in the core network at that time. We can make use of our legacy network, our 4G network. So what we do there is I need a 4G network to be there where you can connect to it. And then when I realize your phone or your device is capable of doing 5G, I then move you across onto a 5G radio bearer. So that's non-standalone mode. So that's what we're seeing being rolled out by operators today. And the reason for that is it's a lower cost investment to start with, and you can build that experience and learning in what 5G will deliver. So, get industry used to what 5G can deliver, get consumer used to what 5G deliver, and then reap the rewards of that and invest in the next phase of 5G, which is the standalone modes. There is definitely a knowledge-based change in the industry when driving this. And the reason why that is, the cellular world has predominantly been the bastion of telecoms engineers. And actually the network as a whole now is software defined. So what you're really looking at is a hybrid between IT, the DevOps technology guys and the telecoms guys. And they don't naturally occur. So we are starting to see that, DevOps and IT guys coming in and trying to learn telecoms, and telecoms guys trying to learn, the IT world of that. So that's slowing things up a bit when it comes into getting people out and involved in the activities as well. So recruitment is quite high, and when things are in short demand, the price goes up. So if you're a 5G engineer, the world's your oyster at the moment. But I think that will change over time as we become more used to it. And as industry pulls and demands that, then the supply of that engineering will be coming as well. In terms of challenges, I think really carefully, it has been hyped a little bit at the beginning. The reality is it can deliver quite a lot, but it's in its early infancy. So, don't judge it today on what it will deliver tomorrow. So I think you've got to get used to it. The consumer will see a difference in speed, absolutely, and that will continue to grow over time as well. I'd like to see more emphasis being put on services as opposed to consumer broadband, and I'd like to see more emphasis being pushed into the adoption of other network connections, such as satellite, being actively involved in the next phase of what we're doing in 5G. And that's really what I'm pushing at the moment, is working in the standardizations groups, defining the new ways we can integrate other networks together. And I think, as things move forward in the next sort of 4 to 5 years, we'll start to see sort of the easier way of getting onto a connection as opposed to the complexity that we see today.
That's a great lead into the next question, which really I'm curious to hear how satellites are involved.
So we've been really active. The European Space Agency, just over 3 years ago, really got on the bandwagon of 5G, understanding what the capability might be. So there was some talk very early on in 5G being the last G. I don't think that's the case. I think we will see more. But it was designed for networks of networks, whether that's a Wi-Fi network or a LoRaWAN network, or whether that's a satellite network. So what we've been doing over the last 2 years is working with the 3GPP standardization fraternity there and defining where we fit technology-wise, where we can integrate the network together, what connection requirements, how we conform with some of the standards, because the satellite industry obviously went off and did its own things and invented some really smart things and did it, but it wasn't done in the same way that the cellular world did it, where it was globally standardized. So what we're doing now is a lot of harmonization in that technology, incorporating, the standardization terminologies into 3GPP. So you'll hear the very first term in 3GPP, which is non-terrestrial network. That is a reference to the space industry and the satellite industry. So in the next few years, you'll start to be able to see the carriers and operators to connect the networks together seamlessly. What does that mean to the end user? Well, common billing, common authentication processes, ability to move across one connection to another without having to disconnect and reconnect, and then the harmonization of equipment and new products and services coming where we're both using satellite and a terrestrial network to provide this complete connectivity capability, regardless of whether you're in a desert or on the top of a mountain or whether you're in the city. The intelligence will be there to decide what's the best connection that you need to be and how do I get you onto my network.
And China just this week launched an experimental 5G communications satellite on Wednesday, and it was built by a Chinese company, and it's expected to test some of the extremely high frequencies. And yeah, I mean, it looks like it's supposed to transmit up to 10 gigabits per second. And it's part of a plan to establish a 5G constellation based on low cost, high performance, small satellite platforms, and really taking advantage of increased access to space through launch and applying Moore's law to satellites. So this is all very interesting. Curious to get your take on really, is China leading here?
The satellite industry is hugely successful on its own. And, I always compare it a little bit to Formula One. They build these fantastic satellites that go in orbit for many, many years and survive. And that's great. Don't get me wrong. But if you look at the cellular industry, what they are good at is mass production. Now, what we could see, and I think we are starting to see, is how do I take that technology in the cellular world and adapt it slightly to survive the space environment? So I get the best of both worlds now. I get low-cost production rather than high cost in the space industry, and the communications innovation area that's happening there and starting to move that. And that's really why I joined the Catapult, was to try and take that learning from the cellular world and say, why can't we apply this in the space industry? Why can't we make 2G or 3G or 5G base stations in space as opposed to bespoke pieces of electronics that serve a purpose for 15 years? So I think that's really what we're starting to see now. The LEO constellations that we're pushing out is one step towards that. There are steps that will follow that, I think, in evolutions of those LEO and GEO constellations, where you'll actually be far more harmonized with the equipments that, technologies that we see in the cellular world coming into the satellite world as well. It's just understanding the risks of employing that technology in a space environment as opposed to a terrestrial.
And do these 5G connections, do they require this type of bandwidth, that high of bandwidth? Because obviously the farther you get down the radio frequency spectrum, I mean, the more bandwidth you have, but the more fragile the signal gets. And this came up back when Facebook was looking at satellites a while back, I think, and they were looking to operate in F-band and a few others were. And you can pump a lot of data through that pipe, but, if there's clouds or it rains or something, then it can really mess with the signal, and you'd have to switch back to something that's a little bit higher up the chain.
Yeah, it's very much true. The higher frequency band, the greater the absorption and a bit of challenge. I think the move to higher frequency bands is not necessarily we want to move there. It's the real estate that's left in the lower frequency bands that are already occupied by existing services. So actually what you really need for effective 5G is a chunk of contiguous bandwidth, 100 megahertz of bandwidth, where you can have that all to yourself to make it a high-speed connection. And we don't have the luxury of doing that in the existing bands that we've got, because at the time we didn't need it. We only needed 20 or 40 megabits of bandwidth. Now what we're seeing is we need 100 or 200 or 500 megabits of bandwidth. And the only way we can do that is to move to the higher frequency bands. And like you said, that comes with a challenge in itself. The propagation is shorter, so I have to transmit more power, or in certain environmental areas, absorption and rain has an impact on that. So I have to understand how that behaves. So yeah.
It makes so much sense. And so back when we were speaking about the software-defined nature of this operating in the cloud, and you were mentioning that people have dedicated spectrum and a dedicated allocation that they're paying for, but they might not be utilizing it all the time. I mean, you need to free up some of that. And by doing that, given that frequency is a scarce resource, 5G seems to be a big step in that direction as well. Better allocation.
I mean, World Radio Forum spend an awful lot of time doing this harmonization and trying to do reassignments and agreeing that. So I think we're going a long way down to realizing that, let's free up the old spectrum that we've been using before for some legacy stuff and see if we can get better use out of it in 5G. 5G is frequency agnostic, and the same as 4G is. It's just that the way that the regulatory and licensing agreements are imposed on a country by country basis that restricts its use really. So, same in the satellite industry. You can be smarter about maybe looking at how we do spectrum assignment in the future. There were big things 10 years ago on cognitive radio, so a very aware radio systems that know about interference and can adapt themselves accordingly. So I think what you'll probably see a little bit in the future is those types of AI being used to define what's the best spectrum band and the best bandwidth to use, as opposed to it being hard-coded within the devices. Right. Certainly the technologies there to operate on almost any frequency band in certain areas. So, yeah, I think we're heading into an exciting future, certainly technology-wise. It's not just 5G or the other things that come with it, artificial intelligence, virtual reality. So, yeah, it's going to be a great time for technologists to be working in this field at the moment.
Right. Okay. So my next question is about Huawei. They claim that they're 18 months ahead of any other 5G manufacturer. The campus in Shenzhen is enormous. If you've seen photos of it, there's 180,000 something employees that work there. Their revenues 2 years back topped $100 billion. And their founder is likened to Steve Jobs, who, built Huawei from a small garage into what it is today. So given all this, we hear a lot about them. Do you think, are Huawei making the most advanced 5G gear?
It's really difficult because 5G is standardized so much the same way as 4G is. So it's really only about time to market. It's not a case pushing the boundaries. I think that comes in the iterations. And certainly Huawei have got a sizable piece of the market. They've invested many, many years ago in building that cellular equipment and capability. So that's grown quite phenomenally over the last 10 years anyway. But there are equally still innovative companies out there doing it. The fact that 5G now is software, and the fact that 5G isn't a bespoke piece of equipment, it's a standard server, there are some radio parts or elements, opens up the market really for new entrants. So yes, they are big, but equally, as you know, over time, it only takes one company to come up with something innovative and get the growth behind them, the investment behind them, and then they could flourish exactly the same way as a Huawei did as well.
Interesting. So as it opens up, we should expect to see a lot more new entrants coming in and trying to capture
there are
some
new
market
things
share.
being talked about, a bit like the open source community in the software world. So things like Open RAN. So, open source radio with software defined radio as well. There are companies in that, like Lime Radio or Altastar or things like that are not the mainstream big companies, but have potential really to get into that market as well. And those sorts of things are really interesting because you can quite quickly flourish as a company and grow quite quickly on the back of, if I can get it out, it's innovative, it meets the market needs, I've got fraternity users that like the way it works, etc., then it can take off quite quickly.
So given all of that, then I'm curious to get your take on the political issues that people keep bringing up, because that kind of throws a little bit of cold water on them. The fear obviously is with 5G, because it's now the connective tissue between things, we start connecting everything in the physical world to it, critical infrastructure, airports, traffic signals, on and on and on, agricultural equipment. So if everything comes online and it's all part of one network, there's a lot of fear there that, who's providing the hardware and enabling that, it's critical national infrastructure. And so obviously, it should stay in-house. And you hear a lot of these types of arguments. But I would imagine that if what you're saying is correct, that the barriers are coming down and we should expect to see a lot more new entrants, then maybe some of that's not exactly as warranted as it seems to be if you read the news.
No, I agree. And like you say, there is a lot of media on this. There's a lot of political unrest around it. But I think, like you say, the way that we're seeing the ecosystem develop, I think that can be mitigated over time. Not that I can comment really on if Huawei are or not doing anything in that area, but certainly I would say that they're not the only supplier of 5G equipment. There are plenty of others still in existence today. So it's just a matter of anybody who's concerned about that making a business decision based on the view of the world as opposed to what we see in the media today.
Okay. And I wanted to ask you also what's next for 5G, but you also teased us at the beginning with 6G, so maybe you could touch on that as well.
Yeah, I can actually. There's a fraternity of people that are already starting. So we're more than halfway through 5G. So like with anything, it's a continuing evolution. We're already starting. What will 6G be? What are the things that because when you design 5G, on the day you start to design it, you sort of lay down the foundation for it. And then you look back over time and you think, we probably should have changed that, or we've come up with a brighter idea of doing that. So I think that's starting to happen now about 6G is, will we have a core network in the future? Will everything just be an intelligent radio system with a cyber agent and a subscriber agent? Do we move away from the traditionality of building networks the way that we've done before? Processing's cheap now, memory's cheap, storage is cheap. So yeah, I think you start to see some more changes around what the core network part of it as well, the consumer won't see. And you'll see some improvements in radio, a little like what you said today. If we can master the high frequency bands and the way that we use them, then we'll start to see even higher bandwidth throughputs that people would be doing, not just the 1 gigabit, but the tens or the hundreds of gigabits in the future as well.
This is fascinating stuff. Okay, Kieran, so what's the best way for listeners to learn more about the 5G Step Out Center and what you're doing?
So best way, we have our website, which is the Westcott 5G SOC. You can find about information on there. Alternative, the Satellite Applications Catapult website as well. We do a lot of outreach. I do a lot of public speaking and events as well. Certainly, I know you can always put my email out there as well. People can email me directly. I'm on LinkedIn, so by all means, always find me on LinkedIn and talk to me as well. As I say, we normally tell it as it is, the good, the bad, and the ugly of 5G. So there's never a question that we can't answer. So we're always open to that. And if people want to come and have access to the 5G center and the test beds, by all means, are always welcome, even if it's just for a cup of coffee and a chat over the technology.
That is a fantastic invitation, and having gone there myself, I would encourage that. We're going to put the links to those websites in the show notes down below. And just to close us out, on this show, we like to say that there's never been a better time to get involved in space investing. Can you give us your personal perspective on that, and which areas, probably, particularly in comms, are most exciting for you?
I think, the CubeSat is really interesting for me. It opens up such an opportunity for innovators in that now, and what we're seeing, the cost of access to space coming down. So I think we're going to start seeing the growth that we saw in 4G in the CubeSat world of the space industry as well. So, and we know there's bright younger engineers coming on board that haven't got the risk aversity of us senior engineers that you see now. So I'm really looking forward to what we start to see in the next 5 years from the CubeSat and SmallSat fraternity.
Kieran, it was really great talking with you. Thanks so much for your time today.
Yeah, it's a pleasure. Thanks, Chad.
Thanks for tuning into the Space Angels podcast. If you enjoyed this episode, please leave us a review on Apple Podcasts or wherever you get your podcasts, and subscribe to make sure you never miss an episode. If you're interested in learning more about investing in space startups, I invite you to visit our website, spaceangels.com, where you can learn all about Space Angels membership and how you can invest in this exciting new innovation economy.